Hello there. In this video, we're going to talk about rules for adding fractions and rules for subtracting fractions. In both situations, you need to find a common denominator. Then you add the numerators only if you're adding, or you subtract the numerators only if you're subtracting, and you'll keep the same denominator in both situations. You'll reduce if necessary. Sometimes it would be easier to understand why these rules are in place if I was able to draw you a picture. And so I'm going to do that for you. And I'm going to show you that if you had a pie and you had half of the pie, or if you had a pie and you had a fourth of that pie, and you wanted to find out how much pie you had altogether, the bottom number is how many pieces it's been cut into, and the top number is how many pieces you have. The bottom number is how many pieces it's been cut into, and the top number is how many pieces you have. Well, it seems difficult to add these together because they're not the same size, so it makes it difficult. But if this pie had been cut also into 4 pieces, it'd be easier to determine that you have 2 of 4 pieces. And then when you wanted to add it together, you'd have 2 fourths plus 1/4. That's 1, 2, 3/4. Now I gave you that picture as a visual aid, but now I'm going to show you how to get the common denominator. We need to choose a number that both of these go into, 2 and 4, the lowest number they both can be divided into. Then we want to determine what we had to do to the 2 to get a 4 and do the same thing to the numerator 1. You have to multiply 2 times 2 to get 4, and you have to multiply 1 times 2, and that gives you 2. So 1/2 and 2/4 have the same value, and you can see that when I redrew this picture for you. When it was just a half, it was this much of the pie, and when it was 2/4, it's this much of the pie. Just in the first situation, it's only cut in half. In the second situation, it's cut in a 4, but it's the same amount. That means these are equivalent fractions. And to take it a step further, 2 over 2 has the value of the number 1, because if something's been cut into 2 pieces and you get both of them, you get 1. Anytime you multiply something times 1, the value stays the same. It does look a bit different when you're dealing with fractions, but the value is the same. If you had half of this pie, it would be the same as if you had had 2/4 of this pie, okay? In this situation, if you don't change the denominator, the numerator is not going to change either. But if you want a more in-depth understanding of that, you could say to yourself, what did I do to the 4 to get 4? And I need to do the same thing to the 1. And you'd multiply them both by 1, and you'd still end up with 1/4. So the rule of thumb is, if your denominator doesn't change, your numerator is not going to change either when you're getting common denominators. Now you only add the numerators, which are the top numbers, and you keep the denominators, which are the bottom numbers. And that's because the amount that these were cut into didn't change. You still had items that were cut into 4 pieces. You had 2 of one item, you had 1 of the other item, which means you had 3/4. Okay, now if your denominators were the same, you still only add your numerators, which are your top numbers, and you keep the denominator. Now if there is something that would divide into both of these equally, like for example the number 4, that's what it means to reduce. But it has to divide into both of them equally, and you end up with 2/3. 5/12 plus 3/12 is 8/12, which reduces to 2/3. Okay, so same denominator, add numerators, bring down the denominator, reduce if necessary. Now when we move on to subtraction, going to have 4/8, and we're going to take away 1/4. Remember, we need common denominators, but I'll give you a visual aid to help you understand why. There's a pie that's been cut into 4/8. You have 4 of them. In this situation, you only have a 1/4. It's a bit difficult to figure that out, but if this had been also cut into 1/8, you could see you have 2/8. So 4/8, take away 2 of them, would leave you 2/8. But I'll go ahead and give you the common denominator. We're going to use 8. What did we do to the 8 to get 8? Do the same thing to the 4. They've both been multiplied by 1. What did we do to the 4 to get 8? Did the same thing to the 1. 4/8 minus 2/8. You only subtract the numerator. Keep the same denominator. That can reduce because both of these can be divided by 2, which I end up with 1/4. So 2/8, which is the visual that I showed you here, also has the value of 1/4, which is the visual I had given you initially. Now, if your denominator is already the same, like 5/6, take away 3/6, 5 minus 3 is 2, 6 take away 6. Well, the denominator is the same, so we're not actually going to subtract there. This can be reduced because they're both divisible by 2. We end up with 1/3. If you want to see what that looks like, if you had something broken into 6 and you had 5 of them and somebody took away 3 of them, what would you have left? 2 out of the 6. If it had been cut into thirds in the first place, didn't do such a great job at that, but those pieces would be equal to each other. Okay, let me give you a better visual on that one. That's cut into thirds. That is too, but I wanted to make it going in the same direction so as to not to confuse you. 1/3 and 2/6, same value. Equivalent fractions. I hope that helped you out a little bit. I hope that it made you realize that fractions aren't quite as difficult as they can appear. And I'll see you soon, or you'll see me soon in my next video.